Let's analyze the convergence of the series sum from n equals 1 to infinity of -1 to the n times n to the n over n factorial. To test the series for convergence, we'll use both the alternating series test and the ratio test. Let's start by identifying the terms of our series. For the alternating series test, we need to check two conditions. First, that the absolute value of the terms decreases, and second, that the limit of the absolute value of the terms approaches 0. Let's look at the absolute value of our terms. The absolute value of a sub n equals n to the n over n factorial. Let's calculate the first few terms to see if they're decreasing. For n equals 1, we get 1. For n equals 2, we get 2. For n equals 3, we get 4.5. For n equals 4, we get 16. As we can see, the terms are actually increasing, not decreasing. Therefore, the alternating series test cannot be applied here. Let's try the ratio test instead. For the ratio test, we take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. Let's substitute our terms. We get the limit as n approaches infinity of the absolute value of -1 to the n plus 1 times n plus 1 to the n plus 1 over n plus 1 factorial, divided by -1 to the n times n to the n over n factorial. Simplifying, the negative ones cancel in absolute value, and we can combine the factorials. This gives us the limit of n plus 1 to the n plus 1 times n factorial over n plus 1 factorial times n to the n. Further simplifying, we get the limit of n plus 1 to the n times n plus 1 to the 1 over n to the n. Using the binomial theorem and properties of limits, this limit approaches infinity. Since the limit in our ratio test is infinity, which is greater than 1, we can conclude that the series diverges by the ratio test. To summarize, we first tried the alternating series test, but found that the terms were increasing. We then applied the ratio test and found that the limit was infinity, proving that the series diverges.